which is basically the layer 2 on the air interface, where you get stuff like, oh, a packet has arrived and I have to acknowledge it, or a packet has to arrive which does not need to be acknowledged. This kind of stuff you get there. Then you have dedicated channel management messages. A dedicated channel is a point-to-point channel between one mobile station and the network. If you're currently making a call, or if you're currently receiving or sending an SMS message, then you will be assigned a dedicated channel from the network, and this is what the dedicated channel messages are for. There's also common channel management messages, which are for not point-to-point channels, but actually point-to-multipoint channels, such as a broadcast channel. Every GSM BTS has a broadcast channel over which it transmits what some people would call beacons. In GSM, they're called system information messages. So constantly, it broadcasts information. Well, I am a cell. I operate on this frequency. I use this network code. My channel configuration is like this. All kinds of information that the telephones need in order to actually access the network. And that is using the common channel messages. And then there's transceiver management messages on AVIS RSL as well. The radio link layer itself, then, just to go back on this. So we have the E1 physical layer. We have the layer 2 TEI management. And we also have the RSL as a layer 2 on that E1 line. And inside the RSL layer 2, you then have the radio link layer header. And from the radio link layer header, you end up in call control, mobility management, radio resource, or SMS messages. So those are the interesting protocol levels, which is actually exchanging signaling information between your mobile station and the network. They're mostly specified in 0408 if you want to have a look at the details of these messages. The equipment we use for BTSs is a Siemens BS11 micro BTS. I'll have pictures just in a second. The Siemens BS11 micro BTS is built in '97, so it's already 12 years old equipment. And at that time, the term micro BTS was used for equipment that has a weight of 47 kilograms. That's the micro BTS. Right? So you can imagine how big at that time the actual BTSs were. Because if you think about the complexity of this protocol and that it has been designed in the 1980s and deployed in the early 1990s, the technology you had available at that time, you needed massive electronics to build such a system. The Siemens BS11 is a plain 2G BTS, so it has GSM voice calls and it has circuit switch data and obviously SMS, but there is no GPRS, no packet data communications, and there is especially no edge or 3G or anything like that. It has 1 or 2 transceivers, which you can each configure from 30 milliwatts to 2 watts transmit power in the GSM 900 band. There's 2 E1 interfaces. Why 2? Well, one goes to the BSC, the base station controller. The other interface, you can go to another BTS, because a BTS with 2 transceivers only uses about a quarter of the capacity that an E1 line has. So you can run your E1 line first from the base station controller to the first BTS, then to the second BTS, then to the third BTS, and so on. So you don't need a star architecture. The documentation is under NDA, but who needs that documentation if 99.9% of those protocols is in the GSM specifications? It literally is that far. There's only very few messages that are vendor-specific. Initially, we just, carbon copied them from existing traces. We didn't even know what they do. By now, we understand what they do, but so you don't even need to understand those vendor-specific bits. It's very, very little. It's an RS-232 serial port for a local maintenance terminal, which is basically a local terminal which you can use to configure, do some initial configuration. There is a proprietary software for that under NDA, but you don't need that for operating the BTS. And we have a free software implementation called BS11 config, which basically does what the LMT would do, but it's not proprietary. If you open one of these, I have a picture of a closed one as well. If you open one of these BTSs, there you will see multiple units in there. It's an RF power amplifier, LNA, baseband, power supply, transceivers, and so on. You don't actually have to open them, obviously, but then, well, we did open them, so I thought I'd show you some interesting pictures. This is the stacking from the side. As you can see, each and every PCB is covered in a massive block of metal for shielding, and even more so for heat distribution. This unit consumes more than 200 watts of power and is only passively cooled by metal elements. There's no fan, nothing inside. The typical operating temperature of the device is so hot that you cannot touch it on the outside. You will burn your fingers, but this is normal operational temperature. No plastics here. This is again from the side. You can see more shielded boxes and SMA connectors. You can see coaxial wires and serial lines. This is the connector panel where you actually connect the transceiver. The antenna here is RX1, RX0 is the two receive antennas. TX1, TX0 is the transmit antennas. And here, those fancy twin-ax connectors is for the E1 line, the four you have here. And then you have a couple of jumpers and auxiliary connectors. And this guy at the bottom is the power connection. Yeah, 4-pin power. Amazing. It's just regular AC power. No, nothing fancy. It's just a connector that is fancy. So how did we go about this? Well, I bought one of these BS11s on eBay in 2006. I started to read some specifications. I built the cables that I needed. And I bought an E1 card that I can plug into my Linux PC to actually establish a physical layer connection. I also found an ABIS protocol analyzer for 99 euros on eBay. Apparently nobody really needs these anymore because the modern GSM networks have different interfaces. So I contacted with some other people who also bought these units off eBay. And I found somebody who was able to provide actual protocol traces of the ABIS protocol. So I had the spec and traces that were supposed to be captured from a real-world BS11 that was working. And doing that, using those two things, it would be possible to do something. Unfortunately, around that time, I had a lot of work for OpenMoko, so I didn't really get any further at that point. Until last year in September, a person called Dieter bought another BS11. He also bought the E1 card, and he started development also using the same traces that I had, and he made very quick progress. Apparently, he wasn't that busy at the time. So what he wrote is a program called BS11 init, which uses the reference code for DAWs that the manufacturer of the E1 card provides. And so this software directly accesses the hardware. It doesn't use any driver layer. It doesn't use interrupt. It constantly pulls the hardware. He ported that to Windows, and I ported it successively to Linux, just memory mapping the registers of the hardware into user space. And it was a proof of concept code based on challenge response. Basically,